before we delve into the proportionality theorems, we're just going to look at some facts about areas of triangles. So the first fact we're looking at here is that the areas of triangles with equal altitudes, that means our perpendicular height from a vertex perpendicular to the base, are in the same proportion as the lengths of their bases. So what it means here, if I've got triangle ABD and triangle ADC, they've got the same altitude, that red line that I've drawn in there, means that the area of triangle ABD divided by the area of triangle ADC is exactly the same as BD divided by DC. And when we look at an example a little bit later, we'll see a bit more as to why that's true. Then we've got triangles on the same base or equal bases. So for example, I've got base QR, and between the same parallel lines, so that line is parallel to that line, are equal in area. So I'm saying that a triangle PQR, the area of that triangle is equal to the area of triangle SQR. Same base, but they're between parallel lines. Then I've got here that triangles with equal areas, so let's say I'm telling you that triangle MNP and triangle ONP have the same area. On the same side of the base, so there's their base NP, then I can conclude they lie between parallel lines. So a line passes through MO and is parallel to the line that passes through NP. So let's have a look at this example. Use the sketches to give a reason for each of the following statements. Now in the first one, they're saying the altitude for triangle ABC is the same as the altitude for triangle ACD, which is true, and I've actually drawn that altitude in here. Because the altitude for ABC is inside my triangle from a vertex to the base, perpendicular to the base, but triangle ACD, there's an external perpendicular height or altitude. And they come from a common vertex. That's how we know that they have the same altitude. Now the second statement here says the area of triangle ABC is equal to the area of ACD. Well, bearing in mind what we've just had a look at, that's true because they've both got equal bases and they share the same altitude because it comes from a common vertex. So I've got equal base, common vertex. Now we look at the other triangle, and it says the altitude of triangle PQR is equal to the altitude of QTR. Altitude of PQR and the altitude of QTR. Well, if I draw in the altitudes for both of those triangles, then you'll see here that they actually have the same altitude because they're between parallel lines. So here's an altitude for PQR. Here's an altitude for QTR. They're both external altitudes if QR is the base. So there's the altitude. So we see for both of those, because they're between parallel lines, they have exactly the same altitude. So I can just say parallel lines. Then they say area of triangle PQR is equal to area of QTR. PQR, QTR. Why is that true? Because they lie between parallel lines and they have a common base, QR. That's just a bit of background as to working with the different areas. Let's now have a look at this example. We're told that BCD is a straight line. Express the following as a ratio of two lengths. So we're starting with triangle ABC and then looking at triangle ACD. So let's first have a look at the area of triangle ABC. Now remember the formula for the area is half times base. I'm taking BC as my base. Let me actually highlight that. I'm taking BC as my base. So it's half times base times perpendicular height or altitude. There's my altitude because it's perpendicular to my base, and in this case it's outside the triangle. That's the area of triangle ABC. I'm going to divide that by the area of ACD. ACD. So it's half times my base. I'm going to highlight my base in blue, which is CD or DC. Half times base times my perpendicular height. Now if you have a look down here at the formulae here, you'll see that different parts of that formula can now cancel. So I can go, okay, my half cancels with my half, and my AN cancels with my AN, and all I'm left with is my BC over DC. So here we can see that area of triangle ABC divided by area of ACD is actually equal to BC divided by DC. Now remember, BC is the base of the one triangle, DC is the base of the other triangle. So that shows you that the area of the one triangle divided by the area of the other, provided the altitudes are the same, is the base divided by the base. So what's the conclusion we can draw from that? The ratio of the areas of two triangles that have a common or equal altitude is proportional to the ratio of the bases of the triangles. Let's have a look at this example. We're asked to express the following as a ratio of two lengths. The area of triangle KNP divided by the area of triangle NPL. So I'm actually going to just highlight those triangles so they stand out. I've got KNP, KNP, and I've got triangle NPL, NPL, NPL. So I want to have the area of the one divided by the area of the other. Now, if they share a common altitude, then the ratio of the areas will be equal to the ratio of the bases. So if I take Kn as the base of the one triangle and NL as the base of the other triangle, then you should see that they share a common altitude. So I'm actually going to pop that altitude in there. Just do it in red. So here's my altitude. It must go from the vertex opposite to the base, which is P. It's a common vertex. And I need to get it to meet that as a right angle. Let's just see why that didn't want to draw there. Let's try that again. Right, so let's draw a line in. There we go. That's at right angle. Okay, so there I've got my altitude. Now you'll see it's the altitude for triangle KNP because it's perpendicular to the base KN, but it's also the altitude for triangle PNL because it's from my vertex perpendicular to where my base would be extended, NL. So I know I can rewrite that as the ratio of the bases, Kn over NL. Alright, now let's have a look at the other one. It says the area of triangle KNP. So I've got KNP and I've got MNP. MNP. So let's have a look at these two triangles in this case. And I'm actually going to take out my highlighting of this one. Take that all out. Because we can look at now the other two triangles. Let me take that altitude out. Okay. So now I'm looking at my KNP. And I'm looking at MNP. So I'm going to highlight MNP now, just so it stands out. MNP. Okay. Now let's have a look if those guys can share an altitude. Now if I use KP and PM as my bases, then my altitude will lie here. There's my altitude. So I know that the area of that green triangle to the purple triangle if I divide them, is the same as Kp divided by Pm, and that's how I get that. Now, if you have a look here, now I'm looking at triangle NPL and NPM. NPM is already highlighted. Let me just go down now and highlight NPL. NPL. Now, if I look at those ones, then they share a common base, NP, and they share a common altitude. They're going to have exactly the same altitude. If you have a look at altitude here, again, let's get our red line in. The altitude for both of these, if that's the base, then this will be the altitude for the one, and here's the altitude for the other. What we can do here is just extend those lines, extend that lines with skew. But anyway, you should be able to see the altitude. There's right angle, there's a right angle. So they've got the same altitudes, they're not sharing it, but it's the same length, but they share a common base, so it's going to be the base divided by the base. They have the same base, so it's NP over NP, which is 1 over 1. Let's have a look at this example. Express the following as a ratio of two lengths. Now we've got some numbers here as well. So I'm looking at the area of triangle ADE and DBE. ADE and DBE. Now ADE and DBE, they share a common altitude. So I'm going to draw that altitude in red so you can see it. There we go. There's the altitude for both of those. Now they share a common vertex. So ADE, my altitude comes from E, and in triangle DBE, my altitude comes from E. So we know now that the area of that triangle divided by the area of that triangle is just equal to the base of that triangle, which is 4, divided by the base of that triangle, which is 3. Let's do the same thing, but now we're looking at the area of triangle ADE and the area of DEC. ADE and DEC. Now my altitude sits in a different position. So I'm going to pop that in green. There's my altitude now. So you can see that altitude, they both share that altitude from point D, from vertex D. So the area of that triangle divided by the area of that triangle will be equal to the base of that triangle divided by the base of that one. So it's the same ratio, it's 8 over 6, which we can simplify to 4 over 3. Now it says, hence prove that the area of triangle DBE is equal to the area of DEC. Now, I'm just going to add in another step here. We know from above that the area, that this ratio is equal to 4 over 3, and that ratio is equal to 4 over 3. So I can conclude that those two ratios are equal. So I can actually write area triangle ADE divided by area of triangle DBE is equal to area of triangle ADE divided by area of triangle DEC. Now if you have a look at that, the numerators in both of them are exactly the same. Therefore, I can conclude for those two ratios to be the same, if their numerators are the same, their denominators have to be the same. So the area of triangle DBE is equal to the area of triangle DEC, because we know that that area is common and the ratios of their bases are equal. We've also been asked to prove that DE is parallel to BC. So let's find those. DE parallel to BC. Well, we know that the area of DBE is equal to the area of DEC. the area of DBE is equal to the area of DEC. And we know that DE is a common base. DE is a common base. And if we go all the way back to what we did on the first page, we'll see here that triangles with equal areas on the same side of the base lie between parallel lines. So that's why we can conclude here. Our altitudes must be equal. We know the areas are equal. We've got a common base, so the lines are parallel.